Okay, so we have another one-dimensional kinematics problem here to practice on. One-dimensional, and I put our kinematic equations right here. That way we have them. It's always helpful to have and look at, just to see what you have, what you don't have, how you can find your unknowns. So this question says, a car starts from rest and accelerates uniformly over a time of 5.21 seconds for a distance of 110 meters. Determine the acceleration of the car. So a few things. Number one, it mentions it accelerates uniformly. That means it doesn't change. And that's one of the big things with kinematics. Sometimes people use kinematics when they're not supposed to and they don't know when to use it. It's when your acceleration is a constant. It doesn't change. So, for example, if you have an object in free fall, you can sometimes, if you neglect air resistance, look at it being a constant. So that's when we can use acceleration. I want to talk a little bit about it. I mostly just want to go through practice examples. I don't want to go through all the details of kinematics, but mostly just practice through them. A few other things I want to note is it mentions that the car starts from rest. That means V initial in the x direction is 0. And then this is obviously the time. Let's do this one. And then this is your delta x. So I'm going to draw a picture first. It's one-dimensional, so we have a car that maybe starts off here. My drawing has not improved. And it ends up here. So from here to here is our delta x. And just drawing a quick coordinate axes. Our origin is going to be right here. So that means your initial position is 0 and your x final is the 110 meters. Okay, so let's look at the equation. We want to know acceleration. And what do we know? Well, we know, let's write it out. X initial, x final, v initial, and the x, v final and the x, acceleration and the x, time. This is 0 meters. This is 110 meters. 0 meters per second. This is what we're looking for. And this is 5.21 seconds. So let's see if we can work through this. Well, I'll highlight it here. This equation looks pretty easy to use because this is 0 and this is 0. So x equals 1/2 at squared. 2x equals a t squared. 2x divided by t squared is our acceleration. And let's see. Calculator time. 2 times 110 all over 5.21 squared is about 8.10. That's not what I wanted. 8.105 meters per second squared. This is units of meters, seconds squared, so the units check out. And there we go.